Morning to you all. You are welcome to the webinar series on water and wastewater management and treatment. This webinar series is jointly organized by the National Environmental Research Institute, NERI, of National University of Singapore, together with the JRDC, Joint Research and Demonstration Center for Water Technology in Sri Lanka, the Ministry of Water Supply in Sri Lanka, the University of Peradeniya, and this event is supported by the Public Utility Board of Singapore's National Water Agency. This webinar series aims at providing a platform for knowledge and experience sharing in the field of water between Singapore and Sri Lanka, and to understand the emerging challenges, water management, treatment strategies to address the future challenges. The target audience of this seminar series consists of researchers, practitioners in the industry, consultants, engineers, and any other who is interested in water. This seminar series consists of 4 seminars. The first one was held in January 2022, and that was on water management and treatment. And this is the second of the series, and 2 more to come in near future. The third webinar will be on stormwater management, and the date will be announced very soon. The fourth one will be on industrial wastewater management. I think you all have got the program for the day. Our sessions will begin with the keynote speech at 11:35 Singaporean time, that is 11:05 in Sri Lankan time. Then followed by, there will be 3 presentations. 2 from Singapore experts and 1 from a Sri Lankan expert. Then finally at 3 p.m. Singaporean time, we will be having a panel discussion. So during the presentation, at the end of the presentation, we will not get a chance to interfere with our specialist, but all audience are kindly requested to be with us throughout this program. And during the Q&A session, you will get a chance to raise your concerns, share your knowledge with the panel members. The panel discussion will be conducted by Professor Nadishan Inanayakara from Sri Lanka. So once again, by welcoming you all to this program, so let me begin by introducing our keynote speaker today. Her presentation will be on wastewater treatment and management, contribution to clean water and sanitation, sustainable development goals. And this will be delivered by Professor Cecilia Tortajada. Professor Cecilia is currently a professor in practice at the School of Interdisciplinary Studies, University of Glasgow, UK, and adjunct senior research fellow, Institute of Water Policy, Lee Kuan Yew School of Public Policy, National University of Singapore. She has received her Bachelor of Science degree on biology from the National Autonomous University of Mexico, then several master's degree. The first one on agricultural sciences from Colegio de Postgraduados, Mexico, and Kagawa University, Japan. Then another one on water resource management from the Royal Institute of Technology, Stockholm, Sweden. Then another one on law and public policy from the University of Zaragoza, Spain, and a double doctorate on philosophy and technology from the Royal Institute of Technology, Stockholm, Sweden. Professor Cecilia has over 25 years of experience on water, environment and natural resource management, agricultural development, and capacity building. At present, she is working on complexity of water, environment and natural resources policy and management, interlinkages of water, environment, food, and energy security, impacts of global changes on water resources, environment, and food. She has served as advisor for several international and national organizations and development agencies, governments, and development banks, which includes UNDP, UNEP, FAO, Canada International Development Research Center, World Bank, Asian Development Bank, International Institute for Applied System Analysis, Inter-American Development Bank, Japan Bank for International Cooperation, Inter-American Institute for Cooperation of Agriculture, INWRNT Capacity Building International, now it is called GIS, as well as for national and state governments in Spain, Germany, Brazil, Cameroon, Congo, Egypt, Gujarat, India, Mexico, Sri Lanka, and Turkey. Competencies have extended to collaborations with Ford and Rockefeller Foundation, Sasakawa Peace Foundation and Nippon Foundation, Japan, Majlis El Hassan Foundation, Jordan, Singapore International Water Week, Stockholm International Water Institute, Stockholm, and multinational corporations like Nestle. So with the introduction, I'd like to warmly welcome Professor Cecilia Tortajada to deliver her keynote speech. Professor Cecilia, you have 30 minutes for your presentation.
Thank you, and thank you very much for your kind invitation. Also, thank you to the organizers for inviting me to give this keynote today. I will be speaking today on the importance of wastewater treatment and management and the contribution to clean water and sanitation SDGs. We know that the Sustainable Development Goals, they are the most recent attempt by the international community to mobilize governments, private and non-governmental actors at national, regional, and local levels to improve quality of life of billions of people in the developed and developing worlds. The goals are an ambitious, challenging, and much needed action plan for people, planet, and prosperity until the year 2030. One of the 17 SDGs is on water. This is the 6th goal, and it is to ensure availability and sustainable management of water and sanitation for all. The achievement of this goal, even if partially, would greatly benefit humankind, given the importance of clean water for overall socioeconomic development and quality of life, including health and environmental protection. We're going to discuss why is it that treatment and management of wastewater is important for the SDG. And I would argue from now that it is because we need water. We need clean water, to which treated and well-managed wastewater contributes to sustain water resources from the quantity and quality points of view. It is also essential to deliver services in terms of water supply, sanitation, and also irrigation. And finally, because of all the impacts of climate change we're already living, to build resilience on climate change, extreme events, and adaptation. So wastewater, clean wastewater, plays a very important role in the delivery of clean water for all users, I would like to start by all of us seeing the world. It is said that the green in the world depends on the blue. This is, wherever we have precipitation, we will have more vegetation. When we don't have precipitation, the situation is different because the countries and cities that are arid or semi-arid, they face different type of challenges. So if we see here in our map, the one we all know, we see those parts of the world that have less precipitation. And together with this, with the less precipitation, we know that population continues increasing. So we have the double challenge of providing clean water supply and sanitation services to an increasing number of population with less water resources. Also in terms of, well, our water resources, we have, many of our cities suffer of water stress, but this is not necessarily because of precipitation, although the impacts of lack or more or less precipitation are important. But this water stress depends on the ratio of total water withdrawal to available renewable water supplies. And this is entirely a human activity. So we need to withdraw more water for our different economic and social activities. In places that are naturally arid or semi-arid, this withdrawal makes water management more difficult. But even then, we are not using the wastewater that represents a very important potential source of water. Where is it that we have these withdrawals? In which sector? We know that most of the withdrawals are for agriculture, followed by industry, and then the domestic sector. And of course, the amounts we have in reservoirs. And it is said of agriculture that it is a water inefficient sector. However, when we irrigate less, also less water percolates to groundwater. We are a system, and water, clean water and clean wastewater are part of the system in order to provide all these services, the municipal, the industrial, and those in the agricultural sector. As a result of all the withdrawals, we have that the groundwater table has declined, and this has been known for a long time. It is basically for economic activities. We don't stop withdrawing because groundwater is needed, but we also don't use the water more efficiently. The question is, could we use treated, well-managed wastewater to recharge groundwater tables? And this has been proven numerous times. So it is possible. This is my point in repeating coming every time to wastewater, to clean wastewater, is just to emphasize the importance that the resource has for areas that are depleted, for growing population, and for increasing economic activities. Water resources, we know, are scarce and are polluted. In this slide, which is from the United Nations, and it is only for Africa, Asia, and Latin America, we see that our bodies of water are polluted, which we have known for a long time. In the case of developed countries, pollution is mainly because of agriculture, because developed countries have established systems to treat and manage water discharges from industrial sources and domestic discharges. But they have problems in terms of agricultural discharges, and we in the developing world, we have problems because of poor treatment of wastewater, of all economic activities. So how does this affect, or does this affect the availability of water, clean water, that is available for drinking purposes? And it does affect. We have in this graph, in terms of water for drinking purposes, that, for example, that we still don't have enough water, clean water, for populations, and this is not only in the developing country cities, but also in developed countries, in places where populations that are marginalized live. They face the same problems, except they have better governance. So we see these graphics until 2017. By now, 2022, still, United Nations says we still have to reach billions of people in terms of clean water, not only water, but clean water. Sanitation is is not as good as in terms of clean water, because many more services need to be provided to larger sectors of population. So we are running behind in terms of water supply and sanitation. And treatment of wastewater has been forgotten, and has been forgotten for many decades, until the SDGs came. When the Millennium Development Goals came, and they covered the period from 2000 to 2015, one of the goals was to ensure environmental sustainability. And the objective of this goal was to provide clean water, and sanitation to a certain percentage of the population. Was this achieved? And there have been many discussions in this regard. In this table, those lines that are in green, they are the MDGs that are thought or considered to have been achieved in 2015. Even before 2015, the United Nations announced that the MDG on water had been achieved. It was not, and this was later rectified. The United Nations explained the mistake, and it was rectified. The mistake was that the improved sources of water were considered, but improved doesn't mean safe water. Improved only means that you compare it with the previous source you had, and which mostly depended on infrastructure, which of course is very important. But the fact that we have infrastructure doesn't mean that water is safe to drink. So what the MDGs were measuring were water of improved drinking sources of water. But again, water quality was not considered. And then SDGs came, because when MDGs were coming to an end, the world wanted to engage in a global goal. And these were the Sustainable Development Goals. And we know instead of having 8, as it was in the MDGs, we had many more. Because by then there was awareness of many other sectors, many other issues on which the world was lagging behind. And then we come to the clean water and sanitation. And this time, it referred to drinking water, sanitation, wastewater treatment, recycling, reuse. It was more comprehensive. And by then, the world had understood the value of wastewater as a resource for the SDGs and for every other activity. So what have we learned in terms of the SDGs? What do the SDGs tell us? They tell us that we are, as I mentioned before, lagging behind. Billions of people still lack drinking water, access to drinking water. Many more billions still lack sanitation. And we shouldn't focus on the number of billions. We should focus on the fact that there is still a problem and that it still needs to be addressed. We know COVID affected the entire world. And what did we learn during COVID about water? We learned that many homes all over the world, estimated at 3 billion, but could be more because of lack of data. But we learned that billions of people do not have access to hand washing facilities at home. We realized this because we were told by the media, by our professors, by our parents, by our families to wash our hands. And that problem we had of having only a little bit of water for certain activities a day became bigger because we didn't have that amount of water that was needed to wash our hands, the number of times we were advised to wash every day. Not only this was a problem at the home level, at the household level, but also in healthcare facilities, where it was found out that soap and water was not always available. And alcohol-based had not been this popular until now. But if let's focus on the basics, on water and soap, we still don't have it. And so we continue, the world continues progressing in terms of technology, trying to address impacts of climate change. We study digitalization, but the basics, which is drinking water, access to drinking water supply and sanitation, still has not been achieved. So we still need to put much more emphasis on these two goals. In numbers, what do we have? And remember, these are very gross numbers, but they point to those issues that we still have to focus on. That about 2 billion people around the world lack safe drinking water, and we know where they are, in places where there is more poverty, which exacerbates the problem. About double of this amount lack safe sanitation. Wastewater is not treated, it's not managed in many places. We lack in many places basic hand washing facilities at home. And we don't have these hand washing facilities we have mentioned. And let's come back to the topic of today's discussion, which is wastewater treatment and management. How does waste treated and properly managed wastewater contributes? How can we use it to address these big concerns? We have here a figure that shows that, as we know, water is a horizontal sector, and it touches a horizontal resource. It touches the life of every person, it touches every other activity in the world. That is why it's so important. So whether we see water as a cross-cutting issue in black, in green, or in orange is immaterial. We need water for energy, for livelihoods, to address poverty issues, to address hunger issues. So water is important. And wastewater, cleanest water, is that source addition that we don't have because we don't have enough water. So then wastewater steps in. What are those places where there has been more understanding on the value of wastewater? And we have, this is from US EPA, we have planned and implemented projects. The projects that have been implemented have been mostly in the United States, which I will show in a moment. We have them in UK. There is one project, but it's only when the river, during the dry season. It doesn't run all the time, the project. In the case of Vulpen in Belgium, it runs the entire project, the entire year. It's very interesting because it was pushed by environmentalists, which is not usual. And it covers environmental and addresses environmental and social issues. Another project that has been working for many years, as we know, here in Singapore from 2002. But even before, is the project from Namibia in Windhoek that has been working from 1968, is the only DPR project, which is a direct potable use from 1968. The ones in South Africa are smaller. And then we have Australia. In Australia, we have mixed messages, right? The project in Perth that has been working for years, for which a lot of working on communication, a lot of effort on communication was put, and where water, as in several places of the United States, water is used to recharge aquifer, different from Windhoek. And then we have the Western Corridor project in Queensland, which was basically cancelled because people and politicians at the end decided not to work in project capacity that go from, in Belgium, in Vulpen, 1.9 million gallons per day to now Orange County has 130 million gallons per day, Singapore 122, but it will have more as more new water plants start operating. This means that there is more water available, more clean water available for more uses. And this means that wastewater is being managed and it is being treated. So our source, our new source of water is the one that has always existed, which is wastewater. These are the number of cities. This is from 2017, so you can imagine that by now, 2022, there are more cities that are already going into either indirect potable reuse or direct potable reuse. But United States is a place where it's a trend. Water reuse has become a trend. And what is more important is that, as in the other cases where there are water reuse projects, where wastewater is managed and treated and has an objective, a purpose, this wastewater is not only produced, but it is only made part of a water demand management program. So in the case of Singapore, there is more water produced through desalination and treating, managing, recycling wastewater. But this becomes part also of water demand management, not only because there is more clean water, this time from wastewater, is that water is going to be wasted. No, water conservation plays a very important part in each city where you see that there are recycled wastewater projects. An example of a city where this potential has been lost for many years is the Mexico City metropolitan area that has grown in terms of population and now has become the Valley of Mexico metropolitan area. Our mega cities, we don't count the people. At some point we say, well, they have more than 10 million people, later on more than 20 million people. And we don't know because there is just immigration. All the time there is immigration. So this city is not, this looks like many other cities in the world. Population has grown too much, resources are not enough, governance is not the best. What is the situation in terms of water? This is a city, well, a valley now, that has traditionally obtained water by taking the water from the groundwater, except it has always been abstracted at a higher rate than the natural recharge. And for many years, for decades, there has been overexploitation, as a result of which several parts of the city are subsiding. And the city has always, because it has grown so fast, always required water transfers. What are the impacts of water transfers? The impacts is that the populations who live in those places that are normally rural areas, and the socioeconomic activities you could have in those areas, they have to be stopped. And this is what happens in many cities, mega cities of the world. Resources, be this water, food, energy, they are brought to the largest center of population. So this is how the city or the area looks in reality. And the red part where we have Mexico City, as you can see on the right-hand side, and we see if almost in the center, and following, if you follow the blue line, that those are the water transfers that come from two of the other states. So you are producing water, you are transferring water, producing and transferring water, and you're bringing it to a city that is highly inefficient. And from where about already some years ago, 45 cubic meters per second of wastewater are produced and are not treated. A very large treatment plant has existed for years, and it is not used on its full potential. So this wastewater that could be used and represent another source of water is not being produced yet. This wastewater that could be part of a water conservation project, that could be part of the system of the city, is not being used. What are the implications for the population? People who are better off, people who live in better socioeconomic areas, they have access to better services. This doesn't happen only in the city, this happens in every other city. The people who are wealthier, they can live in places with better services. People who are poor, they live in whatever place is available, and they don't always have services. So here is a zoom into the water transfers. But my point with this is that this water supply and sanitation for our large agglomerations, they are not efficient. We need them because the populations have grown too much, but not necessarily we have developed systems that are not necessarily integrated, because we cannot integrate what we have not developed yet. But our cities are not considered as a system. We have a problem and we respond to it. And many times without responses, we create another problem. So what has happened that I had mentioned to you in terms of subsidence, many places of the city, you have meters. That part of the city has subsided by several meters. And we can see these parts of the city, how much we can see the static level. And this is a diagram I like very much. All the red circles that you can see, all of them are surrounding what used to be rivers. It used to be a city of rivers. All of them, all these previously cities of rivers that were not treating wastewater, but this means that we already have a way to collect the wastewater. And this means that should we as a city decided to treat the water, it is already being collected. We know that Singapore has been working very hard on the deep tunnel phase 1 and phase 2, which purpose is to collect the wastewater. Well, here in the city, the previous rivers are collected through drains. So they could be, you already have a system that would have to be improved, but there is already a system. Now, next step would be the treatment and the better use. Where does the wastewater go? Mexico and India, several parts of the countries, they have been known traditionally for years for using raw wastewater for irrigation. And it's a sense of pride that is not properly understood. We shouldn't be using it, because with this, we create problems in the environment and related to human health. However, these are the sources of water that are available. And this is a very political issue, because the farmers want the water because it's free, with heavy metals and with all the contaminants we have. But a solution is possible. And now very quickly, I will show the two examples that, two examples, one of the egg potable reuse, which is Bentuk. This is a developing country. And from 1968, Bentuk, which is in a desert area that suffers of extended periods of droughts and that depends on groundwater, and where surface dams depend on ephemeral rivers. They depend on wastewater, treated wastewater, recycled wastewater for domestic uses in the capital city, which is Bentuk. What I'm showing here is that I was mentioning to you that it's not only about producing other sources of clean water, but about managing it. What I'm showing here is water demand management. We have examples of water demand management, what we call successes. So water use increases as it increases all over the world, except in the case of US, that even now they are using less water than in 2015, and in some cases less than 2010. And we have seen the cases where there have been droughts, and the water demand decreases not only because there is a drought, but because of all the work that the water utility does. And in the meantime, every time there is a drought, the production of what would be in Singapore new water increases to provide for the water that is not coming to the people because there is a drought. As part, so more treated wastewater, more recycled wastewater is produced and distributed. And as I mentioned before, is part of a drought response. This is what we have to do to make our different elements part of the same system. So we have information to the population in terms of how to respond when the weather is normal, when there is water scarcity, droughts, severe droughts, or a water crisis. Every time you have more water produced, every time the percentage of water savings also increase. So there is a system that has been set. And the alternative, as I have been mentioned, is water use. It's never about water, it's never about the technology alone, it's about the planning. And it's about considering your water quantity and your water quality and the uses of your water and how do you manage the demand. And then finally, I come to Singapore, where we know that there have been innovation in terms of policy, management, and also in terms of technology. We know of the 4 water taps, but I will focus only on the third one, which is new water or recycled wastewater. And what we have is several numbers. What we have is a plan. It's not the number of new water plants. It's a plan. I want to grow, and one of the resources that are reliable and I have is wastewater. So I manage it properly, I treat it properly, and then I use it mainly for industrial purposes, but also for domestic purposes if this is necessary. So our wastewater becomes one more source of water within a plan. If we don't use it within a plan of water conservation, of water demand management, of development, of growth, then it will also be wasted, as water is normally wasted by all the sectors. Challenges we know all over the world, public perception, in addition to costs. How do not only Public Utilities Board, National Water Agency of Singapore, but every other city that is working on that is treating and managing wastewater and using it, you approach, you deliver a message to the media, members of parliament, religious leaders. You provide public education campaigns. You show the value of it, which is what Singapore has done. And you always keep a positive tone, because having more resources, which are clean, that is always positive. And we always, when we talk about the innovations, we tend to focus on technology, and they are not. The policy innovations are the most important ones. We need long-term planning, the management, the technology, the research and development. Because if we don't do it within these overall plans, then and if we focus only on one resource, then it will not result in all the benefits that it can result if we do it within a broader plan of development. We are diversifying water supply sources, but we should also work more in terms of protection and reliability. We have wastewater, and we will continue having wastewater. It is a reliable source, not only Singapore, as with new water as it is known, but in every city of the world, we have new water. We have, wastewater that can be treated and can be used at different levels. And finally, we're looking for systems that are more robust during events such as droughts. And this is something that climate change has been teaching us. There are problems. We have to address them from now, and we should try to buying time. But wastewater provides services. Wastewater, again, and just summarizing, it sustains water resources. It helps us to deliver services, and it helps us to deliver, to build resilience. So clean water is not, and will never be, clean water is not possible to provide for all users. and will never be possible to provide all the amount of clean water that we need for all uses if wastewater is not collected, treated, and disposed properly for the intended uses. It is a cycle, and we have to learn to consider wastewater as part of water, as our clean water sources for our SDGs at the macro level, and to cover every other need at the micro level. And with this, I finish my presentation, and thank you again, the organizers, for the invitation.
Thank you very much, Professor Cecilia. It was very informative and an eye-opener. You have showcased us the real problems and what we should do immediately. Thank you very much for your presentation. And during the Q&A session, I think there will be a lot of questions coming to you. Thank you very much once again. So our second presentation, the second one will be delivered by Dr. Danesh Gunatilaka. This is on strategy to achieve safe sanitation coverage in Sri Lanka. Engineer Danesh Gunatilaka is a senior civil and environmental engineer. He's currently the Deputy General Manager, Water Reclamation of the National Water Supply and Drainage Board, Sri Lanka. He has vast experience of over 25 years in the water supply and sanitation industry, with 14 years working as a specialist in this sector. He also has international experience, especially in developing regions. Engineer Danesh is highly commended as an expert on strategic and operational leadership in public sector organizations with a track record of driving technological excellence and innovation. He's also a well-known trainer and mentor for water industry professionals. He has published his research work in several national and international journals and conferences. So without taking much time, may I kindly invite Dr. Engineer Danesh Gunatilaka to present your paper. Dr. Danesh, over to you. Dr. Danesh, you have 15 minutes for your presentation. Hello, Engineer Danesh?
Yes, yes.
Okay. We cannot hear you.
Can you hear me now?
Now, yes. Now it is okay. Yes,
okay.
Please go ahead. Yeah.
Okay, I'll continue. So I'll be discussing about strategies to achieve safe sanitation coverage in Sri Lanka. I'll be orienting my presentation in basically in three areas. The recent development of the sanitation master plan by National Water Supply and Drainage Board Sri Lanka, and where we are right now, and technological approach to meet sanitation targets. So that was my presentation outline. So as you all know, the Sustainable Development Goals 6.2 and 6.3 require certain commitments by 2030. So we developed our sanitation master plan based on achieving that targets. So as I can say, the basic sanitation, which implies to Sri Lanka, mainly on on-site sanitation systems, such as septic tank and associated effluent disposal systems, such as soakage pit and soakage trenches, or further treatment options. But in order to become safe sanitation, these on-site sanitation systems, such as septic tanks, need to be desludged once a year, once in 5 years, depending on the design. And therefore, this sludge has to be, safely disposed of or further treated to have the close up the entire sanitation chain. So therefore, safe sanitation, to achieve safe sanitation, we need to consider the septage management or the residual management of the septic tanks as well. So based on our sanitation master plan, we have identified what are the investment requirement for on-site sanitation improvements, then fecal sludge management, then decentralized wastewater treatment systems and centralized seed treatment, and blending the solutions with that. Because Sri Lanka, as you know, our topography changes from mean sea level to beyond 2000 meters above MSL, and it's with the financing limitations of the country, it's very difficult for us to, go for fully covered from public sewer systems. So therefore, in order to have the safe sanitation coverage, which is most required, and we have to have a blend of solutions. So the institutional wise budget requirement has been identified under the master plan, which is rupees million. Now, for example, NWSDB, we need to achieve the targets by having 489 billion. Likewise, local authorities, health sector, Board of Investment, Industrial Development Board, National Housing and Development Authorities have been identified to meet the safe sanitation targets. The financing options, they are from the government side. We have identified several options for the donor financing, direct contracting, and public-private partnerships, and so on. So where we are now, as you can see from this chart, connecting to the public sewer network is mere 2.1% of the 21 million population in the country. So therefore, we can't, meet the safe sanitation targets only from public sewer systems. You can see access to on-site sanitation systems as high as 91.5%, and total basic sanitation coverage is very high in the region. But we have an issue of meeting the safe sanitation coverage. So that is the issue that we are facing. So the technical approach to meet sanitation target, for the development of the master plan, we have used what NWSDB has been practicing in the recent past, has been the strategy to achieve the safe sanitation coverage. So we have on-site systems. So on-site systems can reach up to 100% basic sanitation by year 2030. And since on-site sanitation requires to desludge the septic tanks, we need to have the fecal sludge management. So therefore, we need to cover the fecal sludge management to have a safe sanitation coverage of, say, around 53% by year 2030. And then the decentralized systems. Now, for example, if there are higher population pockets, for example, like a major housing scheme, mixed development, hospital, school, so on, it is very difficult for us to connect that into the public sewer system because it is far away. The investment is not very much reasonable. Therefore, we have to go for independent treatment rather than connecting to the city network. So therefore, these systems has to have a decentralized system, and the centralized system only for the densely populated population pockets of a particular district has been our approach. So by blending these solutions, we are planning to achieve the safe sanitation coverage. Now, for example, the first one is on-site sanitation systems. You can see the septic tank and the associated effluent disposal systems are the solution. And how we are approaching, you can see from the total basic sanitation from 93.6 and how we are achieving 100% by year 2020. And by constructing the on-site, increasing the on-site improvements, as well as total safe sanitation total safe sanitation coverage increased from 9% to 53% by constructing several septage treatment facilities for the districts. Those who do not have any existing wastewater treatment plants that can, accommodate about 2 to 3% of the operating capacity of the such plant for the septage, that is the septic tank sludge taken by the vacuum trucks or the gully bowsers, we call it. So the septic tank systems also we are considering with further treatment options, especially in case when the seasonal high groundwater table is high. In Sri Lanka, we have the coastal belt around the country, and having higher water table. So therefore, we have an issue because if we have the septic tank, it removes only 55% of the BOD, the biochemical oxygen demand of the wastewater. So therefore, still there will be about 110 milligram per liter of organic contaminants that has to be removed before it reaches the groundwater table. As per the Sri Lanka Code of Practice, SLS 745, Part 2, Part 1, 2004 and Part 2, 2009, we have to go for further treatment options in case where the seasonal high groundwater table is high, because soakage pits or trenches doesn't work. So therefore, we had to go for further treatment options like upflow anaerobic filters combined like this one. And we are in the process of, standardizing the concrete septic tanks with in collaboration with Sri Lanka Standard Institute to develop a SLS standard for concrete septic tanks. So the fecal sludge management, we started septage treatment or these septic tank sludge treatment facilities in 2004 December. We had the tsunami outbreak, and afterwards we had some camps for the people who lost their homes, and then we developed the this anaerobic ponds followed by facultative ponds and maturation ponds, the waste stabilization pond systems to treat this wastewater emanating from these camps. So that really paved the way for us to develop the septage treatment plants, and we conventionally went through with these pond systems, having anaerobic ponds followed by facultative ponds and maturation ponds. We changed our approach very recently for when these natural treatments systems such as waste stabilization ponds require a lot of land. So when we can't find adequate lands, then we had to go for mechanized systems. So therefore, our new developments are for the septage treatment is for when we can't find adequate land, we go for anaerobic pond followed by activated sludge extended aeration, then disinfection and discharge in compliance to regulations to inland surface standards, or further refinement if needed depending on the sensitivity of the discharge location. So you can see the fecal sludge treatment plants. We are planning to achieve the safe sanitation coverage by increasing the 9% to 53%, and a number of septage treatment plants, we call it, to treat the stuff that we taken from vacuum truck or the gully bowsers, increasing island-wide to 72 numbers in year 2030. And septage treatment plants, how we are approaching, you can see from this table by 2030, how many septage treatment plants we are planning. It's around 65 at least septage treatment plants around the country.
You have only 2 minutes in here,
Danesh. Okay. Then the decentralized wastewater treatments, you can see here: hospitals, schools, prisons, condominiums, public, and some examples of what we have implemented in the decentralized systems like Ratmana Tsunami Housing Scheme, you can see, and Adams Peak, which is a World Heritage Site, and then different various wetland applications for various applications you can see. And in WSDB strategy for centralized wastewater treatment, we go for the first choice as waste stabilization ponds because it is natural treatment and nutrients are not removed. So therefore it's good for the reuse of agriculture purpose, and helminth XR and other pathogens are removed naturally. And the second option is to go for mechanized system combined with maturation ponds, mechanical aerated lagoons, and when the lands are moderately available, and when we don't have much land, especially our plants are located in a densely populated area surrounded by the residential houses, we go for activated sludge extended aeration with A2O and step feed biological nutrient, depending on the sensitivity of the discharge location. And the first option, you can see Hikadu, which has been an entirely natural treatment. The second one, semi-mechanized treatment. You can see the Kataragama City upgraded treatment plant. And the mechanized one, you can see from Soisapura and Kandy City Wastewater Disposal Project. And our strategy for sludge management is when we have dry zone areas, we go for natural sand dry, and when we have adequate land, but when we have constraints, we go for mechanized treatment with thickening, mechanical thickening or gravity thickening, followed by mechanical dewatering, along with solar sludge drying beds, so that we can granularize the sludge, and that can be used for co-composting purpose. And for effluent disposal, our strategy is to reuse as much as possible. And first of that major wastewater reuse project is proposed for Jaffna. We have got the environmental impact assessment clearances, and we are and the AFD board has approved for funding, but we are still waiting for implementation due to financial restraints. And defense headquarters, again, activated sludge with maturation ponds being in Colombo, we have developed. And this is again for Jaffna, where we are pumping actually 4.5 kilometers upstream for reuse, and we can discharge, direct discharge, as we are meeting the inland surface discharge standards. When there is no requirement for crop water, we can go for direct discharge. And this is again Hambantota. Again, we did not consider sea outfalls for Hambantota because most of the salt production in the southern coast is in Hambantota. Therefore, we went for reuse, and we have got the environmental clearance for that. And our strategy for disinfection will be go for natural treatment with maturation ponds if lands are available. And if we go for ultraviolet radiation, in case where we have the major drinking water intakes downstream, we go for ultraviolet. And if there is no downstream intakes, we go for chlorination by sodium hypochlorite dosing system. So you can see the different interventions we have done. And finally, to conclude my presentation, what we really try to do, blending solutions specific to Sri Lanka to meet the safe sanitation targets, to meet the to protect our environment for future generation. Thank you.
Thank you very much, Engineer Danesh Kunatilaka. Very interesting presentation showing what you have planned for Sri Lanka, and perhaps your project cost, you will have to revisit them and redo your calculations with the recent economic crisis in Sri Lanka. I think you will have to revisit your all plans.
Certainly.
Yeah. Thank you very much once again. And our next presentation is on wastewater treatment and management, sustainability through innovation. And this will be presented by Professor Hao Yang Ng. Professor Ng is the director for NUS Environmental Research Institute, NERI, and the NUS director of SEMCORP, NUS Corp Lab. He is also a provost Chair Professor in the Department of Civil and Environmental Engineering, College of Design and Engineering, NUS. Professor Ng's core research interest is in sustainable water management, encompassing biological treatment processes, including modeling, membrane bioreactor, and microbial fuel cells, and physical chemical processes, namely electrocoagulation, ultrafiltration, and reverse osmosis processes for water reuse, seawater desalination, and resource recovery. He had contributed to more than 350 publications in refereed international journals and conference papers. Professor Ng is a fellow of the Academy of Engineering, Singapore, and a fellow of the International Water Association, IWA. He serves as an associate editor of water research and as an editor of the water reuse. He's also the vice chair of the management committee of the IWA specialist group on membrane technology and a member of the IWA publication committee. Professor Ng receives the 2020 NUS Engineering Leadership Award, 2016 National University of Singapore Engineering Research Award, 2014 IWA Asia Pacific Regional Project Innovation Award, 2009 National University of Singapore Young Research Award, 2008 Singapore Youth Award, 2007 Singapore Young Scientist Award, and in 2006 IWA Young Professionals Award. Professor Ng is currently chairing the NUS Wastewater Surveillance Testing Plan Working Committee. So over to you, Professor Ng.
Thank you, Chair, for the introduction. Thank you very much. Good afternoon, everybody. It's my great pleasure to give this talk on wastewater treatment and management, sustainability through innovation. Now, as we know, wastewater treatment is a very essential part of for all societies to make sure we protect the environment and also to prevent, to control waterborne disease outbreak. So as this is the main objective starting in the early 19th century in terms of wastewater treatment plants objectives. As we progress in the 60s, we realized that all these nutrients present in the wastewater has a great impact on the surface water or receiving water, causing issues like eutrophication. So with that, people start looking into nutrient removal in wastewater. And as resources become limited, as just now earlier on Professor Cecilia mentioned, people start looking at water reuse starting from Namibian, yes. So as we progress in the recent years, we find that people, researchers, practitioners noted that there are tremendous amount of resources present in the wastewater like phosphorus, and potential of recovering other products such as cellulose, VFA, single cell protein, etc. So more and more wastewater treatment plant is being viewed as a resource recovery factories, not only just water, energy too, and also nutrient and other products. Now, so this is certainly a shift into the how we look at wastewater. Instead of a waste and it becoming a used water for resource and recovery. Now, if we're moving forward, as we know that food is becoming very challenging for worldwide, especially with the recent event in Europe, increasingly food shortage is going to be a big challenge for the world. And this concept already, the importance of food for security is already becoming a hot topic in the last couple of years. Now, so many areas in the world, especially in urban city, people talk about urban farming, right? And especially for Singapore, we have the target of 30 by 30, which is to achieve 30% food production by 2030. So with that, how can an urban city like Singapore achieve such a target with such a limited land footprint? So the approach is to have urban farming, right? And of course, we know that urban farming had its pros and cons. When I say about urban farming, typically it means that you are doing, typically it's like rooftop farming, planting your products, vegetables or on the roof, right? And the other approach is to have indoor farming, All right. Certainly, with this indoor farming, you will be very resilient from a climate change issue like flooding or drought, right? Because it's a well-controlled environment. But nevertheless, we know that the cost is going to be high, all right? Because you need to put it within the building inside, and you got to provide a suitable environment for the vegetables to grow, right? So with that approach, you'll find that we need to incorporate all these food, water, and energy nexus, right? Beside the traditional approach of just looking at water and energy. So in all this urban farming, you find that certainly plant need water, and then how do we minimize the leachate and the nutrient that is coming out from the leachate, and then how do we recover, reuse, and optimize this energy? So it become need to be an integrated approach. So basically, urban farming can only be considered sustainable if we incorporate like management of waste products, minimizing pollution and environmental issues to achieve this sustainability, reduction of water and energy use to achieve cost and environmental sustainability, and also reduction of nutrient use. All right, so these are three different aspects to be considered for sustainable urban farming. All right. Now, so if we come back water as a resources itself, this is a classical Singapore approach, which has been in practice since at least about 20 years ago, right? And since 2000, basically closing the water loop by taking the wastewater, treat it to high quality water, and then we call it new water are being then pumped to natural reservoir before it's treated again for drinking water, or the new water is being sent to industry for direct importable use, right? So another approach, of course, we know is seawater desalination. All right. So with this, we can achieve resilience in terms of water sustainability, in terms of water supply. So like nowadays, if Singapore has a short period of dry weather, we do not face any water shortage issue. So that has been done all the while, and it is a very sustainable approach. However, the other challenge for Singapore is that by 2060, the Public Utility Board of Singapore projected that we need to double the water supply from current about 430 mgd, and we need to double this water supply to meet the future demand. And the current demand is about 45% for domestic water use, for 55% for non-domestic industry use. So by 2060, the proportion will be such that the industrial water use will increase to 70% of non-domestic sector use. Now, so certainly water supply need to be increased. Nevertheless, the target is that the Singapore want to achieve such an increase by maintaining the same amount of sludge production, all right, while at the same time minimizing, all right, the increase in energy consumption. Means meet this water demand in 2060 at current energy and sludge footprint. So this is a very, very aggressive target goal. Okay, so especially with this nowadays people talk about decarbonization, the impact of CO2 on climate change. So energy efficiency and is a very huge topic especially for our water industry, right? And sludge issue is that Singapore has limited land mass for landfill capacity to handle this additional sludge. All right. So if we look at water reuse, certainly most of us think about membrane process, right? So in Singapore, membrane bioreactor has been being used to replace the conventional activated sludge process because of the smaller footprint and higher treatment capacity. And at the same time, you produce a final effluent that is of high quality that you can go directly into a reverse osmosis process. All right. So another people are looking into is that how can we recover more water from the RO rejects. So these are looking at technology that can enhance further water recovery. And at the same time, all these researchers and membrane suppliers are trying to optimize, including PUB itself, trying to optimize the process itself to reduce energy consumption. So early on, the PUB have reported that by optimizing the process, the power consumption for membrane reactor can be less than 0.1 kilowatt hour per meter cube of water. Right, so this is an approach to achieve energy efficiency, at the same time reducing sludge production. Now, as for membrane technology, we also look at what are the advances that we can adopt in terms of membrane itself. So example is that there's a more and more plant being expanded or retrofitted using ceramic membranes. So we have also worked with some ceramic membrane companies to look at to demonstrate that this plant can achieve long-term operation with good treatment performance in terms of product water quality, and at the same time durability and stability of the membrane itself, the ceramic membranes. Now, earlier I talked about the new water RO jet recovery. So even after this membrane bioreactor or traditional activated sludge followed by MMUF filtration, this product water will then subject to a reverse osmosis treatment process to produce high quality product water. In Singapore, we call it new water, right? So we know that reverse osmosis can't run at 100% recovery because you will have skilling, fouling, severe fouling in the reverse osmosis membrane process. So typically for new water production, the recovery is maintained at 75%. Means that 25% of the inlet water will end up as a RO brine that typically is being sent for to discharge to through the outfall, right? But we have to keep in mind that this water that the inlet water reverse osmosis, actually there's already a cost that is being put into it in terms of treatment. So can we recover more water out of this water by reducing the RO brine? Okay, so that's where we explore using other technologies such as electrodialysis reverser to recover more water, and then after that, end of the day, you can achieve more than 93% overall water recovery. All right, and then that project has been done successfully with SUEZ, and then been demonstrated that we can achieve this target at a reasonable cost for the additional advanced treatment. Now, of course, carbon emission is another major issue for the whole, it's a hot topic for a lot of these, for our industry, especially, and also other energy sector. All right, so now if we look at the number of paper publication or research being conducted related to carbon emission, you find that the number has increased, I would say like exponentially increasing. And so you find that the CO2 emission for wastewater is one of the topics that people are looking into it. And instead of the traditional activated sludge process where we convert to CO2, are there other processes that we can adopt to achieve energy recovery? So you find that out of all this research, all right, you find that energy recovery comprises, especially anaerobic processes, comprises 42% of the studies, all right. And then microalgae, bioelectrochemical process, molecular fuel cell take up the other 58%. All right, so people are looking at how can we achieve energy recovery. Okay. Now, so if we look at the consumption of energy, all right, throughout the plant, the most intensive use of energy is basically the activated sludge process, right, where the aeration is easily take up a substantial amount of the energy, all right, and then electricity alone contributes 25-45% of the total operating cost. And so the approach that people have done is that can we move away from CO2 like traditional aeration and then go towards anaerobic process, right? Even for mainstream anaerobic process. So with that, there's a potential of from there looking at the resource recovery and at the same time produce methane, and then with that we use this methane for energy production, and at the same time other people are also exploring byproducts of the whole process. All right, and so based on the life cycle study of whole wastewater treatment system, 10% increase in the use of biogas to produce electricity and wastewater treatment will enable 3.65% reduce in greenhouse gas emission in the whole plant. All right, so we do know that by doing biogas recovery through biogas alone, we can substantially reduce because we extract the energy back, right? And before we release it back as CO2 through the electricity production. So with that process, people are looking at anaerobic as a core treatment process. And of course, I would say anaerobic treatment process is not the magic solution to all treatment process, right? At the end of the day, we know that under anaerobic treatment process, you produce an effluent that is low in organics, but is still very rich in nitrogen, phosphorus. So this water, if after anaerobic process, we know that it can't be just discharged to the environment because this discharge is likely to contribute to eutrophication and environmental issues. Nevertheless, if we can, for example, after this anaerobic process, this wastewater is a great permit for agriculture, for irrigation, all these things. So if we can combine anaerobic process with the membrane separation process, of course, we get biogas production, which can be used for power generation or convert to other bio-natural gas like hydrogen. That is possible from the methane itself, and that is the biogas. Now, for the permit, of course, there's high amount of dissolved methane which can be further recovered. This permit will be high in nutrient, and like I mentioned earlier, nitrogen, phosphorus. Then how can we use that? All right, so people talk about direct agriculture irrigation, or even we can use microalgae cultivation to grow algae, which can be harvested for other usage, right? And then we can also potentially look at phosphorus recovery as a HEP. Now, then the digestate can be used for fertilizer utilization, especially if the feed water does not contain any heavy metal. All right, so these are one possible approach that people are exploring. All right, so we look at energy, nutrient, and high value product recovery. Now, if we look at this is a paper published in 2014 looking at how is the energy recovery for the various processes. All right, so you have this traditional like activated sludge with anaerobic digestion or medium strength wastewater, high strength wastewater, and this negative means electricity production. This positive means energy consumption. All right, so you can see that once you for high strength wastewater, you can get a good anaerobic digestion recovery. Now, people projected that if you, for anaerobic MBR with high strength, the energy that recover can be substantial for anaerobic MBR through the biogas production. And that has a great potential to be achieving energy neutral. So this table demonstrates that for future anaerobic membrane bioreactor, there's a great potential to move towards the high energy recovery with decrease in global warming potential. All right, so this is something that is being explored extensively in terms of research and exploration. Now, so the question is it possible to achieve an energy and carbon neutral treatment processes? All right, so this is one of the potential treatment scheme where anaerobic MBR, recovering energy, nutrient go to membrane photoreactor, further porosing, and then you reclaim the water, you recover in terms of nutrient, all right, and algae, all these things, all right. So there's a potential way. Now, the other issue that always have is especially membrane fouling issue. All right, so we have study looking at the traditional way is through a biogas spudging, especially for anaerobic MBR. It's very similar to aerobic MBR. Instead of gas spudging, using a air aeration, now you use biogas spudging. So this has been commonly used. So we explore vibrating through this motion to create a shear force. And we found that the indoor effluent quality is equally good. Then the vibration have very good control of membrane fouling, and then energy consumption is much lower. And with less this biogas spudging, the dissolved methane actually is lower, so that it can enhance the natural extraction, natural emission of this methane gas and capture, rather than we have to go through other process to extract from the water. All right. And then the other issues that people explore is look at the membrane fouling through current quenching. So what is this QQ? Basically, bacteria communicate to each other. When the environmental is stressed, they will tell each other to stick together, and then they will produce all these EPS to make the sludge more sticky. That's how they resulted in biofilm growth. So bacteria communicate by current sensing. So there are certain group of bacteria that can actually consume and degrade this current sensing molecule. And then that can minimize or slow down the rate of membrane fouling. So we've done extensive research to use current quenching for anaerobic MBR. So you can see that this is a rise in TMP versus operation time. For this circle around one is you can see that the TMP increase is much slower. So basically you can extend the operation period between 39 to 135% of the time. So this effectively show that the current quenching is a very promising even for anaerobic MBR process. So in summary, you can see that this anaerobic process can basically we are looking at biomass. Okay, this is another approach people looking at, even looking at biomass for biochar production, water recovery, nutrient recovery. All right, and then these are, and then there are research ongoing to look at even VFF PHA recovery from the anaerobic MBR. Okay. And this one I just now mentioned, this anaerobic rich in nitrogen and phosphorus can use direct for agriculture, irrigation, or go for nutrient extraction. All right. Okay. Now, I think I need to jump off this one because running out of time. Basically, PHA is another approach people look at to recover from the wastewater treatment rather than just methane alone. All right. So in summary, wastewater is a source of energy, water, potential VFA, PHA, and then nutrient NMP, proteins, polysaccharide, lipid, and of course method. People talk about recovery. Okay, so eventually we know that at the end of the day, we need to look at the water management as an integrated approach, and indeed policy and is very important. And wastewater is a resource, and we need to have treat it as a recovery facilities. And certainly you need innovative financial and sustainable business model. And very important, you need policy, institution, and regulatory framework. Okay. Okay, so in summary, we know that wastewater contains many useful and recoverable materials, and then technology innovation is always a key pillar to achieve this better and more efficient treatment process, to achieve better water, lower cost of recycled water, and also lower cost of this resource recovery. And then certainly we need collaborative effort among the different stakeholders, policymaker, regulator, utilities, financial organization, etc., to expedite this paradigm shift. So with this, thank you very much for your attention. Thank you.
Thank you very much, Professor Ng. So your presentation is very informative, particularly for academia and research students who are attending for today's webinar. So you talked about the latest developments in the research areas for sustainable development. Thank you very much once again. And our last resource person for the day is Engineer Go Inch Kwan. In his 25 years career, he's going to talk about Singapore's circular water strategies. So in his 25 years career with Kepler, Engineer Go has held various leadership positions and was involved in the development, management, and execution of multidisciplinary infrastructure projects, including large-scale water, waste-to-energy, power generation, and port facilities. Apart from overseeing the water services and development of water-related projects, currently, Engineer Kwang is also the project director for Singapore Integrated Waste Management Facility, SIWMF, and was the project director for the Keppel Marina East Desalination Plant, which was completed in 2020. Engineer Go holds a Bachelor in Engineering degree in Mechanical Engineering from the NTU. He is a professional engineer with the Professional Engineers Board, Asian Professional Engineers, senior member of the Institution of Engineers Singapore, and fellow member with Singapore Institute of Arbitrators. So over to you, Engineer Kwang.
Thank you. I'm happy to have a session with everybody today. I think the chair have introduced me. I will go straight into the sharing section with regards to Singapore's circular water strategy. Of course, some of the information are also made available on TUB website, but I'm just borrowing some of the information to give you an overview of what is our circular water strategy. Okay, a little bit about Keppel. The Keppel Group actually, in our recent, last year, we have refocused our strategy. So Keppel Future is charted as an integrated business to provide solutions for sustainable urbanization. The area of focus include energy and environment, urban development, connectivity. So under the first group of energy and environment, we have Keppel Offshore Marine, Keppel Infrastructure, which is where I belong to, and we have Keppel Renewable Energies. Urban development, we have Keppel Land, Keppel Urban Solution, and we have a JV company together with Tianjin City Government, which is called Sino-Singapore Tianjin Eco City. For connectivity, we are one of the telco, M1, and of course we have Keppel Data Center and Keppel Logistics. So underpin all these group of business, we have assets management, which our Keppel Capital manage about $36.1 billion of fund, and this provide us an ecosystem of private fund, and also we have some listed REITs and trusts. Okay, overview on Keppel Infrastructure. We strive to improve life and environment by providing solutions for sustainable infrastructure. We invest and develop and own and operate the following type of infrastructure: power and renewable, environmental, new energy. So for power and renewable, we are experienced independent developer, which we own and operate a power plant. We have vertical integrated value chain for the gas to power. We have gas retail, we have electricity retail, and Keppel Energy Nexus, we are the owner and operator of pipe racks, network and utility on Jurong Island. And of course, then power interconnection and city electricity importation. Environmental aspect, we are waste treatment, water and wastewater treatment, and we have proprietary advanced combustion technology with regards to solid waste treatment. We have track record of 100 over projects in 20 countries. New energy, we have district cooling. We are one of the major district cooling provider in Singapore as well as in Asia. We are now embarking on distributed energy services, including EV charging, energy storage, and smart microgrid. And we are also looking into green hydrogen, carbon capture, and storage. Okay, a little bit about Singapore water strategy. Maybe I start off from the rain first because it's easier to explain. So in Singapore, we basically, from the rainfall, we have storm water management. All rainfall fall into the city are now going into the stormwater drain, and then most of it are collected. And we have a collection of rainfall in 17 reservoirs. And after that, it will go through treatment of raw water to potable water at PUB water treatment works. And then it will supply to either the industry or the household. The used water is then collected by 3,500 kilometers of sewer and deep tunnel sewage system towards 4 used water treatment plant. We call it a water reclamation plant. And the treated effluent will then either be discharged to the sea or it will go to 5 new water factories. From the new water factory, after processing, the water will then return to the industrial, or if not, then some of the excess water will go back to the reservoir as an indirect potable consumption. Our water strategy is also supplemented by seawater desalination plant, which today is 5 instead of 4 desalination plant that will supply to the potable network. All right. Now, one thing I want to emphasize over here is that Singapore started off our water management in the right footing. We have our used water to be separately collected from the rainwater. In some country or city, you actually see sewer and stormwater are in the combined sewer. So for us, we separate it so that those rainfall, which is we will call it a cleaner water source, will then directly go into the reservoir. And with that, then in that case, the treatment cost is just only focusing on the sewage portion of the works. So with this, I think it basically summarizes, this left-hand side basically summarizes what is our, how do we ensure sustainable supply of water for Singapore. So we have 4 tags. One is the local catchment, the other is the imported water, and then new water in the chart earlier on I explained is the other source of water, and then another source, another 4th tag is actually the desalinated water. So I move on to the next slide. And Singapore water strategy in detail for local catchment. You can see from this map, our most of our river are actually now already dammed off. So with this, all these river being dammed off, any rainfall within the island itself will be a form of our local water catchment source. All right. And this, by harnessing all this water, this itself increase our total catchment from previously, if I'm not wrong, I think less than 20-30% to now 2/3 of Singapore island surface. Okay. And of course, then the other source of imported water is from Malaysia, which was an agreement signed in 1962 and is expected to expire by 2061. And this, given that there is going to be a water agreement that will be expired in 2061, and that is the reason why PUB and the government had taken a lot of initiative in ensuring that we have other alternative water source, including earlier mentioned increasing the local catchment, and of course then the new water and the desalinated water. So a little bit on our new water and our new water. You can see over here, the first new water plant is the Bedok new water plant. And then the second new water plant was a PPP model, which is later on I will talk a little bit about public-private partnership. This first new water plant in Pandan is built, owned, and by Keppel, and followed by the Sembcorp new water plant at Changi. And then the next one is a BWGUE new water plant, which is a 50 MIGD. And then, of course, then we have a Kranji new water plant. So that sum up where is our new water plant. Of course, in going forward, there likely to be another new water plant at this part of the island, which is next to Tuas Nexus, the west side DTSS, right? So, but that project itself is still not come on stream, but it is an equivalent size as these two new water plant on the east. Then for desalination plant, we have the first Sing Spring desalination plant, which is partially owned by Keppel. And then after that, we have the Tuas South desalination plant and the third desalination plant at Tuas. And fourth desalination plant, which I will talk a little bit more, is the Marina East desalination plant, which is also designed, built, owned, and operated by Keppel. And the fifth desalination plant has just been declared open in this last Sunday SIWW. Yeah. So for new water, as I mentioned, it is not non-potable use, and part of it is indirect potable use. Okay, so the long-term target of Singapore is to increase our water source from for new water from 40% to 55% by year 2060, and desalination plant up the capacity from currently 25% to 30% by 2060. Okay, Singapore water strategy with regards to desalination plant. So we know that desalination plant, the water produced are highly energy intensive. It currently ranges between about 3.5 kilowatt hour per meter cube. And the long-term target of PUB is to bring the specific energy consumption to 1.5 kilowatt hour per meter cube, and then on the longer run to 1 kilowatt hour per meter cube. It's a very, very stretched target, but I think the water industry people are working very hard towards this. And of course, Keppel also in collaboration with technology supplier as well as Institute of Higher Learning to look at this aspect of application. And for some specific on some unique desalination plant, like the one that is built by Keppel, which you can see on the slide. Basically, this Marina East desalination plant is a fourth desalination plant which Keppel owns it, and is produced up to 137,000 meter cube per day of fresh drinking water to the network. This plant is the first dual mode desalination plant. It basically able to extract reservoir water from Marina Barrage or Marina Reservoir and treat it to potable water during wet season. And during drought, the plant is able to extract water from the sea and then treat it into potable water. So some photograph you can see. Some unique feature of this desalination plant is that we are first direct coupling desalination plant in Singapore, but of course in other parts of the world there may be some smaller plant that adopt this concept. The key advantage of this direct coupling of having the UF direct coupled with the RO is that it actually reduces one break tank and one pumping cycle, which every pumping cycle we know that we lost at least 15% of the energy efficiency. So by far, this plant itself is one of the most energy efficient in terms of the process. All right, and of course, this is the first desalination plant that uses ultraviolet as a primary disinfection, and as a result, together with some other innovation, we have made this plant the most compact desalination plant, taking up only 2.4 hectares of land use as compared to a typical desalination plant of about 3.5 hectares for the same treatment capacity. So by doing so, we actually result in our scope 2 ESG emission, our scope 2 emission, right? Okay, a little bit on the approach of Singapore strategy towards water infrastructure, right? Not all the desalination plant or new water plant are generally PPP. What do you mean by PPP is that generally it refers to the government, the agency or organization function under the state budget, which is the public, and private, of course, generally refers to profit and non-governmental voluntary sector or company. So the partnership is generally an agreement between two or more parties. So the type of PPP model at which you can see in the world, it could be BOT or BOO or BOOT, which I think is self-explanatory. So for this Marina Desalination Plant, it is a BOO in nature, but it incorporated the design aspect of things into it. So it is a design, build, own, and operate. Now, there are some concern and advantage with regards to PPP model. Of course, by having a private entity into a PPP model, as they own the asset, they operate it with the operational expertise. The developer building the plant would tends to put in a lot of value engineering to ensure that their approach is basically looking at the lowest life cycle cost. And by doing so, then in that case, with a competitive bidding exercise, then the cost saving may be returned to the general public or the consumer. But there could be another flip side in relation to this. By having a PPP model, in particularly that the private sector is to perform the financing portion, then in that case, there may be not too many of a company having the financial strength to offer a bid. Under that circumstances, then in that case, the competition will be less intense. As a result, the government may result in higher cost of expenditure, all right, in order to engage the service. So there must be a balance in this aspect. And as you can see in most of the PUB, PPP model, it is an international tender rather than a domestic tender. So that encourages more competition to ensure that the saving of the government is ensured, and of course then the public actually does not having to pay for too high a price for the water source. Now, the other advantage of having a PPP model, of course, is project completion and reduced delay. Like Marina East Desalination Plant, I hope there is no consultant here. I can share with you my experience. In Marina East Desalination Plant, a lot of decisions made are within myself and my group. And the turnaround time of decision made is definitely much faster because there are some approval process, yes, internal, and does not need to go through the process of an owner engineer consultant looking through and explaining to him why I do this value engineering, why this material is suitable and that material is not suitable, why there is a slight change in the specification which is in the tender spec, because all these are internalized within the developer. So the completion of project are ensured. We have without having to go through the consultant approval cycle of 14 days and then and then comment of 14 days, reapproval of 14 days. That itself are cut short, certainly. So that is the really one key advantage of having a PPP model. Okay, then ROI of investment might better benefit than traditional project. As mentioned earlier on, with value engineering along the way after the bid, there may be some technology the private developer is more incentivized to try, and with that again with the life cycle cost analysis comparing what is earlier assumed and subsequently what the value engineering will bring about will definitely improve the return of investment. Okay, and risks are fully appraised during the early stage and determine the feasibility of the project, because any project that the PPP model is to be carried out, the private developer will have to look through the financial aspect, the economic outlooks, all right, and of course, looking at contractual terms with regards to price adjustments, CPI index, etc., etc. So on the flip side, as I mentioned, decreased competition may increase the government cost, but however, this can be overcome by increasing the competition, limit the competitiveness as required. Profit of the project may vary. This itself, what is the perspective of this is that in the event that if you were to already enter into a water purchase agreement, what will happen is that you may have a tariff escalation adjustment mechanism by adjusting the CPI according to the CPI index. But however, just take the recent situation, the Ukraine and the Russian war. There are supply chain issue, energy price increase, all right. But the CPI itself depend on how it's pegged. It may not be pegged against the gas price, all right. So when that happens, the gas price or the energy price may have increased at a higher rate than the CPI increase. So when that happens, then it will be at the risk of the developer. So that will affect the profit margin of the developer. But of course, these are risks that any developer will have to face. Right. The last point about on the flip side is that in the event that the government outsource all this critical infrastructure to all the private sector, when there is a crunch, the government may not have total control. Okay, this is the flip side. And I think in Singapore, what you can see in most of the Singapore water asset, all right, the WRP, the water reclamation plant, are totally controlled by the government, which is PUB. Only the new water portion is outsourced to a PPP model, but in the contract, all right, of this water purchase agreement, the government withhold the step-in right. So this is to ensure that the government will have full control of the asset in the event that there is any dispute. So of course, all these flip side and disadvantage have been carefully thought through. So I would give the credit to the government as and PUB for that. Okay, sorry. Okay, now PPP model. If we were to look at some of the PPP model, how shall it be adopted in overseas, and some of the risks that as a utility developer, how do we see it? Okay. Now, most of the time, as a utility developer entering into a new country or a new region, we would look at the authority approval and permitting process, because when we are in Singapore, things are very structured and very clear, made very clear. So the approval process is not so much of a concern. But in the event if you were to go to a foreign country, you as a developer, you may face difficulty, whether is it in the form of EIA, construction permit, etc. So this may, as a result, result in project delay, and project delay is never good for both the developer as well as the government or the consumer. We all know that. The other aspect is demand predictability. Whether is it, of course, wastewater treatment plant, we want to know whether or not there is a fluctuation in terms of the influence coming into a wastewater treatment plant. Is it changed seasonally, or if it's not changed seasonally, because a capital cost recovery is depending on how much water do you treat or how much water do you supply. So the predictability of the demand, whether in the form of influent or product water, have an impact to the financial model. If the predictability is not certain, then in that case, the developer will tend to put in a bigger safety margin, and the bigger safety margin may not necessarily translate into benefit to the government or the consumer. Okay. Then the other thing is energy source and its security. We know that any facility, whether wastewater or water treatment plant, will require energy to run it. And if the energy source and the energy security is not able to ensure, then in that case, it will result in inability to trade or inability to fulfill the contractual obligation.
Engineer Kwang, can I finish it in minute?
Yeah, I'm finishing.
Okay,
Yeah, I'm finishing. So the other thing is security of payment. This is one of the key aspects for any investor, is that how sure are we able to receive payment, particularly if the treatment, the product water is supposed to be sent to individual household, and how whether or not there is a potential of default. And of course, then the other aspect is currency risk, which any investment, whether it's in foreign currency and the receivable is in local currency, is there a fluctuation in currency risk? So I think before any PTP can take place, I think the government role is to consider all the above risks and then see whether if there's any mechanism or policy to address. I think with that, then I think all these are our track records, which I will not run through in detail, but basically we are one of the, these are all private partnership experience from waste to energy to new water to desal plant and water reclamation plant. And with that, I end my presentation. Thank you.
Thank you very much, Engineer Kwang. And we have now reached the end of the first session of today's webinar. I must thankful to the organizers for organizing a very important webinar for our participants. So let me thank our keynote speaker, Professor Cecilia Tota Jada, for spending her valuable time with us. Then our three experts, Engineer Danesh Gunatilaka, Professor Yang Ng, and Engineer Kwang, for giving us very, very informative presentations. Since we are running 20 minutes behind our schedule, after thanking the organization team for inviting me to be the MC of this session, I'll wind up this first part and hand over the panel discussion to the moderator, Professor Nadishani Nanayakkara. So for our panel discussion, we have, I think, still we have 30 minutes to raise questions and get answers from the experts. Over to you, Professor Nadishani.
Yeah, thank you, Professor Kalpage. Yeah, so now it is the time for our Q&A session. So I think you can direct your questions to through Q&A facility in Zoom. So until we receive questions from the participants, I would like to start the discussion, maybe few questions, maybe until we get questions from the participants. And now, listening to Engineer Go's presentation and linking that with Professor Cecilia's presentation, I thought of asking a question from Professor Cecilia. Now, when it comes to this PPP, especially when we operate under BOO or BOOT, the profit expectations of private sector, maybe in a country like Singapore, that the concern can be lesser. But if we think about a developing economy, how practical that would be.
Prof. Cecilia, you want to take the answer? I will take the answer.
You can take the answer, Mr. Go, please.
Okay, I give my perspective. All right. As long as there is a very clear framework of the water purchase agreement in the tender stage, and as long as there is a very clear legal framework of ensuring each party's risk and obligation, with that very clear outlook, the developer would be able to price their risk margin as low as possible. Okay, so I can give you some ballpark number. In Singapore, our ROI is definitely less than 8% for any investment of water asset. So it's a very marginal marginal profit for any investor. Of course, if you were to invest water asset or even utility assets in overseas, sometimes you may see as high as a ROI of 15 to the extent of 25%. So increasing ROI, not necessarily that the developer will be able to reap the profit, because there may be some risk which they have not accounted. Their actual ROI may not be that as high. But with that, then in that case, does it benefit the ultimate consumer? So I think earlier on in my presentation, I talked about the risk, in the risk perspective of any developer. All right. In order for a PPP model to work, the government and the private sector or the private developer will really have to find a mechanism to address all the risks and concerns, so that in an equitable manner, so that the developer is able to reduce their expectation of ROI. I hope I answered that question.
Yes, yeah, yes, clear. Thank you. Yeah, there is a question to Prof. Ng. I think it might have answered online, but I think for the other benefit of the other attendees, I would like to ask the question again. Yeah, how about the energy consumption for creating vibration in ANMBR process against backwashing? So if you compare between, yeah.
So this question is that backwashing is still required, but what I mean, if you compare biogas spudging versus vibration, vibration is lower. I cannot remember the percentage, but based on our experiment and also computation, the vibration energy requirement versus biospudging is lower. Okay, so that is what we have found. But I think backwashing we will still require as part of the regular operation. Okay.
Yeah, thank you, Prof, for the clear answer. And yeah, there is one more question here. How can countries like Maldives, probably I think this question is asked considering, kind of similarities between Maldives and Singapore probably, improve the resilience of their wastewater when the key challenge is a lack of centralized systems for treatment, processing, and reclamation.
If I can comment on this without having worked on in Maldives, but the problem of our developing countries is that the problems have grown to such extent that now when we talk about resilience, which is very much a new word, we find that we have to first develop infrastructure, systems, we need financial resources. So perhaps is, and again, I have not worked in the Maldives, but it is very many more. There are more challenges that only lack of centralized systems for treatment, because in many cases the places are going for decentralized systems because they are easier. Like Mr. Wall was explaining many times, is decentralized, right? But it depends very much on the location. So I think that the resilience depends on more aspects than only the fact that a system is centralized or decentralized. Thank you.
Yeah, maybe I can comment on that. I'd like to share my view. Yesterday, when I attended the forum, I also give my view on this aspect. There is always a debate about centralized or decentralized system. Now, if it's in a very urbanized city like Singapore, or any city that is very urbanized, the construction of interception sewer is less costly because the network itself is, although intensive, but is definitely shorter, right? Then in that case, it makes sense to have a centralized sewage treatment system, all right? And having a centralized sewage treatment system with your water, used water reclamation, you can easily put the downstream new water system, which is recycle your used water, all right? Now, if you are in a country whereby it's less densely populated, the town, there are town, but the town itself is a low-rise building and very spread out, then in that case, I think definitely a decentralized system will make sense. At least as a town planner, I would do that. Okay. So now on Maldives, I have not worked on Maldives, but during my earlier years in 2005, when the tsunami hit in 2004, together with TUB Capital, have donated a desalination plant to Maldives and helped to build, I think, 700 meters of distribution water network to the village. My take about my view about Maldives is that if there is the government must have the will to decide and do something on the sanitation system. Earlier on, I think there was one presenter about on-site sanitation. Every household, if you want to address a problem, every household or maybe a community of a couple of houses, you can actually build an on-site sanitation system, and that should be able to solve water issue. But of course, by doing on-site sanitation system, to look at the option of having a water recycling, it is less feasible. Okay, that is my take. But if it's a distributed, decentralized wastewater treatment system, anything above 2,000, 3,000 meter cube per day, there is still a possibility of doing a water reclamation. Okay.
Thank you. And the same question, maybe Engineer Dhanesh have some experience, maybe if you consider the centralized systems, even in Sri Lanka, we might have similar issues. So I would like to listen to Engineer Dhanesh's, inputs to this question. So how can countries like Maldives improve the resilience of their wastewater when the key challenge is a lack of centralized systems? So similar problem maybe there in Sri Lanka as well. So yeah.
In Sri Lankan experience, we have kind of a blending the solutions because now, for example, if there is a kind of a housing scheme, I have explained in my presentation, like Ratmalana Tsunami Housing Scheme, Tsunami Resettlement Housing Scheme, where we have 324 housing units, and then we can have an independent collection network, and then we have the treatment with then again the 4-storied housing units have 2 units have a common septic tank. Then we have a gravity network and a lifting station, and then we have a upflow anaerobic filter followed by subsurface constructed wetland chlorination and discharging to Lunava Lagoon. There is a channel that leading to Lunava Lagoon. So there where we have to go a little bit more than the inland surface discharge standards. I think likewise, even for several housing units, you can implement a decentralized system, as well as even for individual houses also. It may be possible to do reuse of treated effluent. But only issue is that, the house owner have to have the knowledge of, maintaining such a system. You can have a septic tank or anaerobic filter, and if you need, you can go with pressure filtration and activated carbon filtration. But then there will be operational intensive. So the house owner have to manage such a system. So then, like other presenters mentioned, the reusing will be kind of a issue. So other than that, you can see ISO 3050, where you can, implement any system which does not create any environmental issues like odor or discharging treated effluent. So you have to basically manage the treated effluent. So if one individual house is managing, then they have to finally, if they are not reusing, especially in a high rainfall, high rainfall is in that area, particular area, then it may not be possible to reuse the entire treated effluent. So therefore, you are compelled to discharge it to a municipal stormwater drainage system. So therefore, you have to meet the regulatory compliance and get the approval of the local authority. So there will be a lot of challenge for individual reuse, and the system might fail in case if the house owner cannot, operate the system. because like package treatment systems, for example, if they incorporate it, then they have to maintain the internal recirculation systems, blowers, so many other interventions are linked into it. So in Sri Lanka, what we are trying to do is, we have this SLS 745, we are trying to develop on-site treatment system that does not require energy. So the simple house owner can, manage this one. And whether it is, if the seasonal high groundwater table is higher, like in the coastal zone of Sri Lanka, so then the soil percolation will be through a soakage is also quite difficult. So therefore, maybe soakage trench may be feasible, or further treatment options are the most feasible, and that can be operated by a individual person. We have to develop that type of a system, or otherwise we have to go for decentralized system, where then we can manage the larger effluent discharges, meeting the required standards of the particular country. In Sri Lanka, we have inland surface standards. If we are to discharge to near shore, we have to meet a high level of treated effluent. For example, if we are to discharge to transitional waters like coastal area, then we have to go for BOD less than 15, total phosphorus less than 1, like that. But if you are discharging to an inland surface water body like a river, you can go BOD 30, and phosphorus and nitrogen removal is not so much of concern at that situation. Okay. I hope I have answered the question.
Yes. Yes. Thank you, Engineer Danish. It is, I think we can think of many different other methods of handling the same. And there is another question which I would like to direct to Prof. Ng. Prof. Ng, the question is, how did COVID-19 pandemic shifted the paradigm in wastewater treatment and management in Singapore? And what can be learned from your experience that can be adapted in country like the Philippines?
Okay, this is a good question. If you look at this COVID-19, I think the first impact is that a lot of places use wastewater as a surveillance tool. So we did it in Singapore, and it also happened in many parts of the world, including US, many countries. So basically, they take the wastewater and then check for the the RNA fragment of COVID-19 virus. So as an indicator of community, the catchment area, any infections. So in the early days, people use it as a tracking source. Means if you discover fragment, then you know the wastewater catchment units got people get infected, then you can do a swab test. That was the early days of the pandemic. But nowadays, people use it as a surveillance, whether there is increasing trend or decreasing trend of number of infection. So that is what happened in Singapore, in NUS. We do that, and then when I talked to my friend just a few days ago from New York, he's a professor. He's doing that for his campus, all right. And then he give indicator that there's a lot of infection case, and then the school decide to instruct people to compulsory wearing masks, all these things. So it become a very powerful tool. So likewise, other utilities has been using that as a tools for detecting of the polio, the infection disease, all these things. So certainly people are exploring that, both putting into implementation, adoption, and using it as a surveillance tool, or people are doing a lot of R&D, how to use wastewater surveillance as an infectious disease indicator. Of course, there are utilities outside talking about using that as a detecting of any drugs, illegal drugs usage. Then somebody taking illegal drugs in certain catchment, So these are people talking about. All right. So other than that, if you talk about impact of wastewater treatment, I believe utility will be very careful because certainly you know that this COVID fragment of virus is going to be in the wastewater. But this is issue. This is for the operator, plant operator, safety precaution. But this issue has all the while been there, right? Because we know that there are potential pathogens in the wastewater. So in terms of safety and health management, day-to-day operation must have this in mind. So other than that, if you talk about, okay, and another interesting issue is that maybe Professor Cecilia can mention is that I just heard in the conference, they were talking about this lady from the World Bank talking about now because in COVID time, you talk about asking people to wash hand more frequent, all these things. So having a safe supply of water for washing hand is important. All right, how are you going to wash your hand if you want to implement that, right? So this is an issue with water supply. All right.
Yeah. Okay. Thank you, Prof. And there is a question to Engineer Go. Why not trying to extend the agreement with Malaysia rather than trying for desalination as an expensive option?
It's a good question. I think I would not be able to answer that. I think it's very much at the government level. Of course, I think Singapore have definitely every intention to extend the water supply agreement. But however, we also need to understand the Malaysia government, having that they are also developing or improving their economics. So any increase in economy activities will result in higher water consumption. And given that, then in that case, they may be also competing for the same water resource. So in the event that they view that the water resource is inadequate or maybe due to climate change, the water resource is depleting, the agreement may not extend. We won't know, all right?
Yeah, true. Okay, and another question, I think, since carbon emission was discussed at Prof. Ng's presentation, I would direct this question to Prof. Ng. Is there generally an overemphasis on carbon emission targets over water resilience? Actually, Prof. Ng, the same question is with me too. So yeah, it is interesting to know.
This is a very good question. Now, if you ask my personal thoughts, okay, of course, I would say achieving energy efficiency is extremely important. When you talk about carbon emission, right, you're talking about, so when you ask this question, if you ask me whether you're talking from a research angle or talking from a practical point of view, let's say I'm talking from a practical implication, okay? Because when people do research, they're also trying to explore new ideas, exploration. But a lot of this idea is still in the exploratory phase. Now, if you ask me carbon emission, of course, we know that we want to have energy efficiency. This is very important because if you use less energy, means your carbon footprint is lower. Then, of course, the other question people was talking is that where is your energy source? If your energy source is fossil fuel, of course, adding energy efficient, you reduce your carbon footprint. But alternatively, you say my energy is from renewable energy. Then, but reducing the energy efficient is also very important because I got excess energy for other application, right? So carbon efficiency is very important in my viewpoint. But if you ask me water resilience, if you I would say it's a priority. I think, of course, first thing, water resilience is the ultimate most important. If you don't have water resilience, what are you talking about? You can't even survive with the water supply, right? So in my viewpoint, that is priority. Now, of course, other than that, then you need to look at carbon emission issue. But strictly speaking, I would say, if you look at the whole water treatment sector, I think the carbon, early on people talk about nitrous oxide emission, all these things, but statistics told us that we are not the major emitter, rightfully, right? Wastewater consumption is substantial, but it's still not the highest in terms of carbon emission. So I think it's important, but I don't think, to answer your question, I think water resilience, in my viewpoint, is our first priority. Yeah.
Okay, thank you, Prof.
And if I can also
Yes.
add to what Professor Ng has said, the decarbonization is very new. It has been known by scientists, but the global awareness is very new. And so we are shifting. It's true, like the world is jumping into the need to decarbonize. However, the primary goals, the main objectives for get resilience, remember that's also a new word, but the basic services, which is clean water, that has existed since the beginning of humankind, and that still remains as a priority. I don't think it's one or the other. Decarbonization has become one more challenge, but water will always, clean water will always be the first goal to achieve.
Yeah. Okay, thanks, Professor Cecilia. So I think we are in the last 2 minutes. So I expect a very brief answer from Engineer Danesh for this very last question on composting. So how safe is it going to be, the proposal to compost?
Yes. Now what we did was, we have implemented several solar sludge drying beds for to enhance the dry solid content, and also to deactivate pathogens, because during the daytime in the solar dryer, the temperature in the solar dryer can rise up to, say, around 40-45 degrees temperature. So therefore, based on the retention time that we want, because most of the composting persons, the private sector composting service providers, they doesn't want to dry at a higher level, because otherwise they will have to input water there again. So therefore they like 4 days retention time. And to ensure the safety, what we did was, we have we have requested the International Water Management Institute, IMI, and their resource recovery expert, Dr. Sudarshana Fernando, we came with their staff, and they have independently collected samples, and they have recommended, because we have checked with the EU Council directive, as well as US EPA and the Sri Lanka compost standard itself, and studied, and pathogens were checked, and the heavy metals were checked, and what they recommended was to have a better safety, ensure the better safety, use sewage sludge 1/3 with other constituents, because sewage sludge has a lot of phosphorus and other nutrients. We are using nutrient removal plants at Mortu Ratmalan and Jayalekala. So therefore, what they recommend was 1/3 with other constituents, so they can have a better compost material.
Okay.
But I'd like to add a little bit about this energy discussion that we had earlier. Now, Water Board, we are trying to implement waste stabilization pond systems as our first priority, because there is no mechanical devices to fail. You need only maintenance to remove the scum and weed growth in the pond systems, and a lot of land is available currently, and you can use it for the future as well, because you can upgrade the capacity of the plants, because as long as you have the land availability. So that is why we give the priority for pond systems. Other aspect is that facultative ponds generate, it is algae bacteria biosynthesis, where the algae in the presence of sunlight, they produces molecule oxygen that will be utilized by the facultative bacteria during the day with aerobic treatment. But at of the facultative pond, you don't need any algae. So if we take up algae, we either as biodiesel or as a biomass, can be used as a energy source. We can in the future there will be a lot of potential, and also you can get a lot of carbon credit, because carbon dioxide emissions are taken up by the algae. And also the only disadvantage that we have, anaerobic ponds generate a lot of methane and other stuff. So there will be a balance between both of them. So I hope I have answered questions.
Yes, thank you so much, Engineer Danesh, for your answer. And though there are a few more questions in Q&A session, since we are already, beyond the time given to us for questions and answers, I would like to kindly request the participants to, direct the questions to our panelists after the webinar, maybe through email. So with that, I would like to thank again our keynote speaker, Professor Cecilia, and then the three speakers of the day, Engineer Danesh Gunatilaka, Prof. Ng, and Engineer Ko, for your inputs and sharing of the knowledge with all of us. So with that, let me close the session for the day, the webinar series 2 on wastewater treatment and management. Thank you so much and have a nice day.